Alright, so let's finish up with lucky last example 13. This one's a little bit challenging because there's quite a bit to read through, and it's a little bit challenging to visualize and see what this whole scenario looks like, but that's all good. We can work through this together. So example 13 says, a surveyor records that the top of a nearby church steeple has an angle of elevation of 5 degrees, and the top of a clock tower has an 8-degree angle of elevation. From his position in the middle of a paddock, the church steeple is located at north 10 degrees west, while the clock tower is at north 15 degrees east. If the tops of the church steeple and the clock tower are both 30 meters above the level of the surveyor, what is the distance between them, which is the distance between the church and the clock? So this is a 3D scenario. Not only do we have bearings on the floor, indicating where the church and the clock tower is from this person, the surveyor, we also have, looking upwards, the angle of elevations to the top of the clock and the church. So let's first by trying to draw a diagram of this. So we have a surveyor in the middle of the paddock. Alright, I'm just going to call him surveyor. We're told that the church is a bit west of the surveyor, while the clock is a bit east of the surveyor. So something along the lines of, if this is the church, because church is a bit west and clock tower is a bit east, and then on the floor I draw my north, south, east, west indicator just so I can see. So that's north, south, east, west, right? So if I, on the floor, connected the church of the surveyor, hopefully you're using your straight edge tool, your beautiful rulers, to give me straight lines. Oh, come on iPad, let's do this. Give me a straight line. There we go. And I'm also connecting the surveyor to the clock tower. So this is on the floor, right? So zooming in, if I'm just purely caring about bearing wise, ignoring the heights, so looking at bearing, the church is north 10 degrees west. So this floor bearing is 10 degrees. Well, if I just change color, the clock is 15 degrees east of the surveyor. So purely just looking at the bearings, that's 10 degrees and that's 15 degrees over there. Now, what makes this a bit more challenging is, let's change color again. Well, the clock and the church actually have a physical distance, physical height, sorry. So we're now told that, oops, that's not what I want. So the clock tower is 30 meters tall and the church is also 30 meters tall. And then the thing is, when I try and connect the surveyor to the top of the clock tower, using a straight line again, hopefully you're using a ruler. So I connect the surveyor to the top of the clock tower. It tells us that the angle of elevation of the clock tower is 8 degrees. So what I do know that is, from the floor, the surveyor looks up a turning of 8 degrees. And we also know, well, we're assuming that the clock is perpendicular to the floor. We don't really want a leaning clock. And similarly, let's do a similar drawing to the church, the top of the church to the surveyor. So if we connected the top of the church, straight line tool with the surveyor at the floor, the bottom of the ground, hoping you're using a ruler as well, the angle of elevation of the clock is 5 degrees. So zooming in, the surveyor has to look up 5 degrees. So this angle here is 5 degrees to be able to look up to the church top. And again, we're assuming that the church is perpendicular to the ground. We don't really want a leaning church tower. So what we're trying to find is the physical distance, horizontal distance between the church and the clock. So if I use a straight line tool and draw a line connecting, come on, the church, come on iPad, to the clock. Why won't this work? Okay, this is not working. I don't like how unstraight. That will have to do. We're trying to work out that red distance there, which we can call x. Let me put that in red. That horizontal distance x between the church and the clock. At the moment, this is a bit hard to annotate over. So suppose we're going to flatten the 3D triangles of the angle of elevation so that we can just see triangles flat on the page. What would it look like? Well, it would look like something like this. So I've got the surveyor, I've got the clock, and I've got a church. I'm connecting the surveyor and clock together, and I'm connecting the surveyor and the church together, and I'm also connecting the church and the clock together, and that is the distance of interest. If I laid flat the vertical clock tower, and it's like pushing down the clock to the floor, so we do get that right angle triangle down on the bottom because we're assuming the clock is built perpendicular to the floor, and we're also flattening the church angle of elevation triangle, so we get that this is a right angle. This here is 8 degrees because it's the angle of elevation flattened. This here is 5 degrees because that's the angle of elevation to the church. The angle inside, this angle inside is just the angle inside the 10 and the 15. So that orange angle inside is 10 degrees and 15 degrees, which is 25 degrees. Yeah. So if we flattened our 3D image, then it looks like 3 triangles, in particular 2 right angle triangles and 1 triangle in the middle. Our goal is to work out that distance x, that horizontal distance x. So the question is, how do we do it? Do we use the sine rule? Do we use the cosine rule? Well, the right angle triangles gives us a hint to use SOHCAHTOA already because we've got angles, we've got right angle triangles. So, I forgot to label that. We also know that the height of the clock tower is 30 meters and the church is 30 meters. And this would help us because if we can apply SOHCAHTOA, so we've got opposite, and maybe we can work out the adjacent side. Then we can use tan to work that one out. So opposite and the blue adjacent side. And in fact, that would help us because if we can work out the 2 blue sides, then we've got 2 sides and an angle squished between, and we want to work out a 3rd side. So that is perfect for the cosine rule. So our game plan is using SOHCAHTOA because we've got right angle triangles. We can work out the 2 blue sides, and once we know the 2 blue sides, and since the orange angle that we know is squished in between our 2 sides, and we're trying to work out a 3rd unknown side, cosine rule is the way to go. So let's define some variables first. So I'm going to move this up a little bit so I can give myself more space. Right, so let's define the variables length A and length B. Yeah, so let x equals distance between church and the clock, it'll be measured in meters because our other measurements are given in meters. Let A equal the distance between church and the surveyor, again in meters, and let B be the distance between our clock tower and the surveyor in meters. So as we mentioned before, the purple triangles, to work out A and B, we can apply SOHCAHTOA because it's right angled triangles. In fact, we have opposite and adjacent sides, so we can use tan. So tan of theta is opposite over adjacent. So let's work out the church triangle first. So tan of 5 degrees is 30 over A. In other words, A is 30 over tan of 5 degrees. Using a calculator, that's approximately 342.9. So 30 divided by tan of 5 degrees. Make sure your your calculator's in degree mode. Similarly, let's work out tan of 8 degrees. So that's opposite, which is 30 divided by B. So B is 30 over tan of 8. So that's approximately 213.46 meters using a calculator. Then we agreed that we can use the cosine rule because we've got two sides and a squished angle and trying to work out the third side. So using cosine rule, quote your default formula, cos of my angle C is the sum of the other two sides squared, take away my side squared, divided by 2 lots of the other two sides. So my angle is the orange angle because that's the only angle I know, 25 degrees. If orange 25 degrees is my C angle, then my other two sides is the sides which I'm squishing the angle between, which is A and B. So that's 342.9 squared plus 213.46 squared minus x squared, because that's my side which I'm trying to work out, divided by 2 lots of 342.9 times 213.46. This is all just calculator work now. So cos of 25 degrees times 2 times 342.9 times 213.46 is 342.9 squared plus 213.46 squared minus x squared. So x squared is 342.9 squared plus 213.46 squared minus cos 25 lots of 2 lots of 342.9 lots of 213.46. So x squared is on a calculator 30445.54. Oops, I'm out of space. Let me create a bit more space up here. Okay, so if x squared is that, then x is the square root. So x is plus minus square root of 30445.54. But we reject the negative answer because distance is positive. But so reject negative square root since distance is positive. So in other words, x is the positive square root of 30445.54, using a calculator, that's approximately square root answer button 174.49. So answering the question, what is the distance between the church and the clock? So the distance between the church and the clock is approximately 174.5 meters. So therefore the distance between the church and clock is nice, approximately 174.5